Okay, so we're going to take a look at the difference between area and volume here. So to consider an example, we will use this one on this interval. So if you're calculating the area, go ahead and pause the video and do that. A little bit of practice here. You'd have this area hither. Now the volume we're going to try to do, I alluded to this the other day in class, we're going to take this thing and we're going to spin it around the x-axis. A little hard to draw and visualize, so when you do that, you sort of get, first off, what you're going to get, this is now to do a volume, this is going to kind of reflect down here. So this is going to kind of come around. Maybe we can get some people with better drawing skills to draw some of these in class. Maybe it sort of looks like a dish on its side, or a parabolic bowl opening this way. So we're trying to find that particular volume. And the way we're going to do it is much akin to the way we found area. We're going to take one of our representative rectangles. Right there, we know that rectangle has a width of dx and a height of f of x. In this case, f of x is the square root of x. And we're going to spin one of those representative rectangles. And when we do that, first off, we find out that our reflection is a little bit off. When we spin one of these rectangles, we get that shape, which is a cross section. I'm going to pull that little cross section out over here and lay it on its side. Looks like this. And we observed in class that, however briefly, that this little cross section would be a cylinder. I'm going to have to scroll down off of here. So what we picture is we're adding up a whole bunch of cylinders. So there's one here. Now I'm going to really muck up this drawing. And there's another cylinder here. So in the same sense, another cylinder out here. In the same sense that we calculate the area by adding up a whole bunch of rectangles, we're going to calculate the volume by adding up a whole bunch of these discs. These are referred to, if you're reading examples in the book, they'll call these discs. But they're really just cylinders. And the volume of a cylinder is pi r squared h. And we're almost done. In this case, the radius, you'll notice from up here, the radius of one of these is the function. And the height is dx. So what we want to do is we want to add up all of these disks from 0 to 4. And that's going to look like this. Volume is 0 to 4 of pi, I'll write this out, pi times the f of x dx. This is the radius. This is the height. We're adding up all of those from 0 to 4. In this particular case, that's going to look, we can pull the pi out there, 0 to 4, square root of x squared dx. And then we just have to evaluate that definite integral. I'll leave you to evaluate that definite integral. You should either do that, this one certainly pretty simple fundamental theorem of calculus, or use your calculator, whichever one. Okay, so we're really kind of, I'm sorry, I'm getting all crooked here. Really making sure we understand how to turn, how to get our definite integral. This is our key step here. So what you should do, try to do the following. I'm going to give you 2 different problems to try for homework tonight, so you can kind of review this and see how that works. Here's what I would like you to do. Oh no, I'll put that with single side. First, I would find a piece of paper. Aha. Here's a piece of paper. So here's the first one I want you to do. I'll make it nice and easy for you. We'll take this function, which of course is good, y equals x squared plus 1. So we're looking for this region. We'll just go 0 to 1. This region spun around the x-axis. And just to help you a little bit, you should probably just draw your own. That's going to look like, yeah, that's going to kind of look like, what is that going to look like? Ooh, kind of the end of a speaker, like if you took a samurai sword and chopped off the end of a trumpet. That's what that would look like to me. What's it look like to you? Okay, see if you can cast that into a definite integral, and then evaluate that definite integral. And then I want you to do the same problem, except, and I'll redraw it. Take this region and see, what if you spin it around the y-axis instead? Here, I'll draw that real quick. So that's problem 1 for homework. The second problem to try is this one. Same function, same region, except spin it around the y-axis. So, bloop, it's not going to be the same thing. Spin that around the y-axis, and we get sort of a bird bath? I don't know. See if you can find that one. All right. Have fun.